negative infinity to 5, okay? Then negative infinity to 2, and 3 to 5. Then we have negative infinity to negative 2, negative 2 to 2, and then 3 to 5. Okay. How many of you, by raising hands, chose the first one for domain? Okay. All right. Second one. Okay. Third one. Second one is correct. The third one, interval of continuity. Okay. So, looking at the domain, left to right. Okay. So drag your pencil. All right. We go straight across. Negative 2 is included because we have a closed circle versus open. Keep going. And then we get to positive 2. But then there's a jump. So we wouldn't continue to 5 because we're missing some of those values. Okay? So we have negative infinity to 2, union 3 to 5. Okay? Because there is a space in between those 2 points. Yes? Closed overrides an open. Okay? So there's a space in between 2 and 3 that we have to show in our domain. Okay? Now, for intervals of continuity, you're breaking it up, okay? Because this is not a continuous function. Why? Why is this not a continuous function? Yeah, David? Okay, so if I use my pencil and I get here, I have to remove it, lift it up, and move it to another point. Then go across and lift it up. So it's not a continuous function. There's breaks in the graph. So intervals of continuity only uses parentheses. So this is your interval of continuity. However, any bracket you see is a parenthesis. Okay? So we first do this first interval, negative infinity to negative 2, union, negative 2 to 2, union, 3 to 5. Okay? So the domain, all right, has just that little break between 2 and 3. Interval of continuity, though, as soon as you lift your pencil, the graph is broken. So it's not continuous. Okay? What is my range? James? Mm-hmm. Okay. Anybody else? Yeah, Jax? Okay. David? Okay. So we have negative infinity to 2. So you bring your pencil this way to 2. And then we have 3. 3 by itself. But closed circle overrides it open. Right? So it would be 3 by itself. Or y equals 3. Same thing. Yep, Campbell. 3. Here. The solid line means it's included, just the 2 endpoints. So that goes back what Kate was asking. Closed circle overrides an open. All right. All right. So that's what we're going to see. Our domain is going to change a little bit in terms of some graphs, all right, that we see. And we're going to take this large domain and restrict it even smaller, all right? So for 2A, what type of graph is this? Jaden? Linear. So where would I start? Y equals 2, and then what? Okay, or what else? Down 1 to the right 3.
How do you know when to go like left and right or like negative?
If it's negative, you always go down and to the right. Okay, down and to the right first. To go in the opposite direction, what's the opposite of down? Anybody? Up. What's the opposite of right? And that's how you go. Okay, to complete your graph. So if it's negative, you're going down to the right. If it's positive, you're going up to the right. And then in the reverse. So here is your line. Okay, very simple. B. What kind of function is this? Catherine? It's a quadratic. And what do we know about a quadratic? Yep. How do I start graphing this? What do I know? Which is? Nope, you're right. Stick with that. You don't need to. What is the HK? Good. Perfect. That's what you need, the vertex. Okay, here's your vertex, and you could plug in x values, or remember the pattern. F1/1, 2. Okay, here's our quadratic. All right. Then number 3 is write the equation of the graphs below. Okay. How about 3a? Someone who has not answered yet. Charlie? Good. Y equals negative x plus 4. You could start with your y-intercept and see what the slope is, or you could use your x-intercepts and find the slope if needed. But always remember, as you're looking at it left to right, if it's decreasing, it's going to be a negative slope. For B, what's my equation? Noella? Excellent. Good. Okay. We know our vertex is negative 3, 2. We know it's reflected. Reflected means the negative. X plus 3 because it was a negative 3. Squared because it's a quadratic. And then plus 2. Excellent. Okay. How many of you got 1, 2, and 3? Well, actually, let's rephrase. 2, correct. All of 2, correct. All of 3, correct. Good. Awesome. All right. So now, we're going to throw just a little curveball. All right. We're going through the library functions. However, we're looking at a restricted domain. Does anyone know what that would mean? Restricted domain? Yeah. Perfect. Yeah. So you're only looking at a small little portion of it instead of the whole graph. So a restricted domain is a portion of the graph's domain in which will be given an interval notation. However, you will also see this in inequality notation as well. Okay. Now remember, if there is a bracket in the domain, what type of circle should there be? Ryder? Closed. Good. Okay, so if there's a bracket, meaning if it's greater than or equal to, less than or equal to, also, okay, you're going to have a closed circle. If there are parentheses, open, which is called a hole, meaning there's a hole in the graph, all right? And for inequality notation, there's no line underneath, all right? So if we restrict the domain from 3, 9, it means the graph should only be shown on x equals 3, open circle, and x equals 9, closed circle. So that's what it means for a restricted domain. So now if you turn the page and look at number 1, first few, we're going to break it down, okay, to see what it's looking at, what changes. But then we're going to get into a lot less words and just jump right into it. So, what type of function do we have here? Let's see, hold on. I want to give people some. Kate? Absolute value. Okay? So we have the absolute value function that has a vertex of what? Same people. Tommy? 3, negative 5. Okay. So we know our vertex is 3, negative 5. Okay, so we could plot that already. 1, 2, 3. 3, negative 5 is our vertex. Now, they're giving us a domain 0 to 5. So how do we find those two endpoints? What do we do? What should we do? Kate? Perfect. Awesome. Okay. So we're going to start on the left side, which is 0. So we plug in, substitute x equals 0. So we have 2, 0 minus 3. Okay, what is our corresponding y value? James? Careful. It's okay. Okay. 1. 6 minus 5 is 1. So our first point, 0, 1, is that going to be an opened or closed circle? Kate? Careful. Why? Why'd you change? It's included, it has a bracket. So this would be a closed circle at 0, 1. Okay? Then we have to do the right side, which is 5. So we substitute x equals 5. And what do we get for corresponding y value? Checks? Negative 1. Good. So we have 5, negative 1, which is this one going to be open or closed? Right. Open. Good. Okay. Because it's a parenthesis. Nope. It's a bracket and parenthesis. Right here. Bracket, parenthesis. Okay. So before we're able to connect, we know this is going to look like a V shape, right? I hope all of you are saying yes, some way, shape, or form. It's absolute value, so it looks like a V shape, all right? So what can we use with absolute value in order to create a good graph instead of just an estimate? Yeah, Kip? You could use slope, which is what value? A, H, or K? A. So we could use the 2 in front as our slope from the vertex. So with absolute value from the vertex, I could use my slope of 2. If I go up 2 to the right, I also have to go up 2 to the left. Now, if you don't remember that, can we always plug in values between 0 and 5? Yes, you could do that as well. Okay, here's an absolute value function on a restricted domain, okay, from 0 to 5. If you don't remember the slope for absolute value only, okay, we could plug in values between 0 and 5 to get a well-rounded graph, okay, an exact graph. All right, let's try number 2. Okay, what graph is this? What equation is this? Eleanor? It's a quadratic, good. It's a quadratic function that has a vertex of what, Kaylin? Good, -1, -3. Okay, -1, -3. That's our vertex. All right. And then we need to find a point at -3, x equals -3, and y, or x equals 3. Okay, we need to find those y values. So we are going to substitute it in to our function. So on the left side of the domain, we substitute in -3. And 0.5 is our 1/2. We know that. Okay. At -3, what is our corresponding y value? Jax?
Well, they actually do.
It is -1. You are correct. Okay. So we have -3, -1. Is that going to be an open or closed circle? It's going to be open because it is a parenthesis. So -3, -1, open circle. Okay. Now we have to do the same thing on the right side. Okay. So we're going to substitute in x equals 3, if you haven't done so already. Oops, that's not 3. Okay. What is our corresponding y value? Grant? 5. And is that going to be open or closed? Closed. Good, because of the bracket. Yes, you may. Thank you for answering too, by the way. Okay. So here, you want to, we know it's going to look like a U shape. Okay. You want to try your best to plug in any other x values between -3 and 3. Okay. The reason is you want a well-rounded graph and exact graph. Okay, because we know it's 1/2. Okay, we know it's 1/2. So I know there's a point here and a point here. And I know it's going up. Yeah, that's fine. As long as you see the shape of the graph. Okay. And some of them that you're going to do, it's going to be very clear what the shape of the graph is, especially if you know what the vertex is and you have 2 points on either side. All right? All right. And the last one we're going to try together, actually the last two. Number 3 is what type of function? Kate R. Number 3, when you get there. Okay. Yep. Square root function. Okay. It is the square root function. Okay, so it's like that one-sided thing. And we look at the starting point, which is our HK. So Nick, what would be our starting point? 2, 1. Good. 2, 1 is our starting point. Okay. And they also gave us the domain of 2, which we found already. And it's a closed circle. That's our starting point. Okay. And then they gave us the right side, which is 6, which is going to be, let's see what our y value is. Okay. Did you get a y value of 3? Yes. Okay, is that going to be 6, 3? Is that going to be open or closed? Okay, good. Okay, open, 6, 3. Okay, and you could also plug in another x value here of 3. Okay, 3 plus 2, 3 minus 2 is 1. The square root of 1 is 1. 1 plus 1 is 2. So I know there's another point here. All right, one other question that we haven't done yet. Looking at this restricted domain, what is our range of this graph? Of just that piece that's shown. What's our range? Riley? Good. 1 with a bracket, 3 with parentheses. Campbell, question? You could, but we already found it. Okay. But if you could, say if you didn't realize that, because at first I don't think I even realized that. So I plugged in 2 minus 2, which is 0. The square root of 0 is 0, plus 1. You get the same point. Okay? Yes?
So, when you find the range to the y-axis?
Correct. So y values. All right. Now, number 4, we have not really seen that yet. Okay, number 4. Because the domain is what? Everything has been from one point to another. Now this one is what? Negative infinity. So what's going to be different about the endpoint? Eleanor? Good. It's going to have an arrow. All right. So this type of function, as we know, is absolute value. Okay. What is my vertex of this absolute value? Yeah, Kate. Perfect. Good. Negative 2, 3 is my vertex. Okay. And they're only giving me one x value to check out. Okay. But we could check out as many x values as we want. What does this mean? Yep. So we're choosing values less than, right? Okay, good. So we could start with 2, x equals 2, because that's the one given to us. We know our vertex is negative 2, 3. What is the y value I could use? 2 what? Jax? Good. So we have 2, negative 1. Is this going to be open or closed? Yes. Yep. Good.
Negative.
We can't input it, so we're... Nope. I'm going to show you 1 second. 2, -1. Okay. If this is our vertex, right? What is, since it's absolute value, what is our slope? Eleanor, careful. -1. So that means this is my last point I could reach on the right-hand side. So if I go down 1 to the right and to the left, I could do the same thing. However, on the left-hand side, what can I include? Yes, James. An arrow. Because it's from -infinity to 2. Okay? -infinity to 2. So, you start with a point. You know your vertex is another point. Then for absolute value, you would use the slope. Or you could choose a bunch of x values, like Kate said, that are less than 2. What is my range of this graph? Jax? Perfect. Excellent. -infinity and 3 with a bracket. Okay? So, the last thing I am going to show you today, turn to, I think it's page 5. So this one here, in this box. I'm going to show you today, you guys are going to graph 2 individual functions, okay? But we're really going to get into this next class. But I want you to see where this restricted domain is coming from, okay? What we're doing is we're creating a piecewise function. So a piecewise function is defined by 2 or more subfunctions. So you have 2 or more equations, okay, on different parts of its domain. So you could look at 2 or more equations, but it's on a little piece of their domain. So this example to the right, okay, is a piecewise function. Okay, we have 3 separate equations here over a piece of their domain. Okay, by doing a piecewise function, it still passes the vertical line test because we have 1 open circle and 1 closed to make it a function. If we had 2 closed circles, like both equal to, then it wouldn't be a function, and we wouldn't create a piecewise function. So all piecewise functions that we are going to see will be functions. All right? So what I want you to do, I want you to graph these 2 functions, so a and b, using the restricted domain. Okay? Graph a and b using the restricted domain. Okay. You should have gotten both of these graphs. Okay? You have your linear function only from -infinity to 1, and it's a closed circle at 1, 3 because there's a bracket. The second function is a quadratic from 1 to infinity. So 1, 3, 1, -3 is an open circle. We know our vertex is 2, -4. Then you could either plug in x values from 2 on, okay, to get your well-rounded graph. Now, when we merge them together, if you notice below, they create a piecewise function, okay? So, let me try this in the other class. Let's see if it works, okay? This is what a piecewise function looks like. Your first equation and the domain, second equation and that domain. So, this one is here. Shows 1 point, but that's fine. Is here, and I'll just add that open circle. Oops, I have to move it down a little bit. Okay. Okay, so here is your piecewise function. Okay, you graph two individual functions on a restricted domain, and then you merge them together to get a piecewise function. Okay, that is what we're going to be doing next class. Okay, we're not even going to graph both separate equations. We're going to jump right into this. Okay, by finding your starting point, which is always plugging in the piece of the domain. Okay, then you plug in x values that work. All right, so for this one, 1 is like your boundary point. Think of it as, and then use it like that, as an electric fence, right? If a dog goes through an electric fence, what happens? They get shocked, right? So 2x plus 1, if it goes past 1, it will get shocked because it's not in that territory. Okay, it's in the blue territory. All right, so that's when we go through piecewise functions, we're jumping right into it. All right, the restricted domain is easier for you to understand. So your homework, if you turn to, in the notes, page 4, five through 8. Okay, page 4, 5 through 8. And then on page 9, where it says 1.6, practice 1 through 4. Okay, this is page 9, 1.6 practice 1 through 4. Okay, so page 9, 1 through 4, and page 4, 5 through 8. This is all on Google Classroom plus additional videos.